Bravais lattice in 2 and 3 dimensions. There are 5 Bravais lattice in 2 dimensions. One is a general, oblique, and 4 spatial. In this, A bar, B bar are translational vectors and phi b an angle. In this first type is a oblique lattice. In this, A is not equal to B, phi is not equal to 90 degree. The oblique lattice is invariant under rotation of pi and 2 pi about any lattice point without further restrictions. Second is a space lattice. In this, A is equal to B and phi is equal to 90 degree. That is, four-fold rotation requires a square lattice. Next, hexagonal lattice. A is equal to B and phi is equal to 120 degree. Rotation of 2 pi upon 6 about an axis. Fourth one is a rectangular lattice due to mirror reflection here. In this, A is not equal to B and phi is equal to 90 degree. Second one is centered rectangular lattice. In this, A is not equal to B, phi is equal to 90 degree. Bravais lattice in 3 dimensions. In 3 dimensions, there are 14 different lattice types. The several crystal systems in 3 dimensions are cubic, orthorhombic, tetragonal, monoclinic, triclinic, trigonal, and hexagonal. There are 3 lattice types of cubic system: PIF, 4 lattice types of orthorhombic system, PCI and F, 2 lattice types of a tetragonal system, PI, 2 lattice type of monoclinic system, PC, 1 lattice of each triclinic P, trigonal P, hexagonal P crystal systems. Here, P is a primitive unit cell. It has atoms only at corners. C is a base center unit cell. It has extra atoms at the center of the base. I is a body center unit cell. It has extra atom at the center of unit cell. F is a face center unit cell. It has extra atoms at the center of each face. The restriction on a translational vectors A bar, B bar, C bar and angles between them alpha, beta, gamma for each crystal system is explained below. Bravais lattice in 3 dimensions. First type is a cubic crystal system PIF. In this type of crystal system, the 3 axes are equal and perpendicular to each other. That is, A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. These crystals have 3 types of lattice depending upon the shape of the unit cell. In case of cubic crystals, there are 4 three-fold rotation axes along the diagonals of the unit cell. The 3 types of unit cells are: first is a simple cubic. It is a primitive cell and the atoms are only at the corners of the unit cell as shown in a figure A. Next is a body center. It is not a primitive cell and there is one more atom at the center of the unit cell in addition to corners atoms as shown in a figure B. Next, face centered. In this unit cell FCC crystal system, there is one more atom at the corners of each face in addition to corners atoms as shown in a figure C, and it is not a primitive cell. Okay, these figures are the simple. First is a simple cubic, next is a body center, and third is a face centered. Okay, next, orthorhombic crystal system. In this type of crystal system, there are 4 types of unit cell P, C, I and F. There are 3 mutually perpendicular two-fold rotation axes. In the crystal axes are unequal. A is not equal to B, not equal to C. But they are perpendicular to each other. So, alpha is equal to, beta is equal to, gamma is equal to 9. Figure 1.13 shows the orthorhombic crystal system. Okay, third one is a tetragonal crystal system PI. In this crystal system, the crystals axes are perpendicular to each other. So alpha is equal to beta is equal to gamma is equal to 90 degree and 2 lateral axes are equal. That is, A is equal to B but B is not equal to C. Okay, in this crystal system, there are 2 types of unit cell. First is a primitive and second is a body centered as shown in a figure A and B. This crystal is characterized by a 4-fold or tetragonal axis of symmetry. Next is a monoclinic or monosymmetric crystal system. In this type of crystals, there are 2 types of unit cell. First is a primitive and second is a base centered. In this crystal system, Axes are unequal, that is A is not equal to B and B is not equal to C, and one axis is perpendicular to other two axes, that is alpha is equal to beta is equal to 90 degree but gamma is not equal to 90 degree. These cells are shown in a figure. Figure 1.15 shows the monoclinic crystal system. Fifth one is a triclinic or asymmetric crystal system. In this system, neither the three crystallographic axes are equal nor the angles are equal. Means A is not equal to B, not equal to C, and alpha is not equal to beta, not equal to gamma 90 degree. The unit cell of this type contains atoms only at the corners and it is a primitive. Sixth one is a trigonal or rhombohedral crystal system. In this type of crystal system, three axes are equal, that is A is equal to B is equal to C, with equal angles between them but not equal to 90 degree, that is alpha is equal to beta is equal to gamma is not equal to 90 degree. The unit cell of this type of crystal is as shown in a figure 1.17 and it is a primitive cell. Hexagonal crystal system. The unit cell of hexagonal crystal system has 8 faces. The two equilateral axes equal, A is equal to B, and intersect at an angle of gamma is equal to 120 degree. The third vertical axis of different length, C, is not equal to A or B. At right angles to the equilateral axis, alpha is equal to beta is equal to gamma. The unit cell is a primitive cell. This figure is a hexagonal crystal system.